So the next concept is Huygens principle. Huygens principle of secondary wavelets. Okay. Huygens principle of secondary wavelets. So this is on the basis of wave theory. Okay. So basically what does it tell is, it tells how a wavefront propagates. Okay. And secondly, it talks something about secondary wavelets. Here the important point that you need to understand is WF, wavefront, is different from wavelet. Listen to this carefully, you'll get the answer. Okay. So I will write down the statement, please copy it. The principle is based on the following assumptions. So this Huygens principle is based on the following assumptions. So first, each point on a wavefront acts as a secondary, each point on a wavefront acts as a fresh source of new disturbance. So acts as a fresh source of new disturbance, which is called as secondary waves or wavelets. So now read the statement carefully. What are they trying to say? Not what are they. What did Huygens principle tell us? Each point on a wavefront acts as a fresh source of new disturbance, and the new disturbance is what is called as secondary waves, or more technically secondary wavelets. So that is the first point. Okay, I leave some space. Second point, secondary wavelets. Okay, secondary wavelets, underline this word. Secondary wavelets spread out in all directions, with speed of light in that medium. Okay, they will start spreading in all directions with what speed? With the speed of the light in the particular medium in which these wavelets are getting generated. Okay. And the third important point is the wavefront. Okay, I'll be more specific. The new wavefront at any later time, is given by the forward envelope, that is the tangential surface in the forward direction of the secondary wavelets at that time. So write down the statement. It is very, very important. I'll explain it. So let me explain each point. Listen to this. So the meaning of the first one is, Let us say I have a point source. What do I have? I have a point source, and that point source is going to generate a wavefront, okay, which is going to be spherical in nature. It's not circular, it is a spherical wavefront. So each point on this first wavefront that is getting generated, that is, if you take individual points here, then these individual points will start behaving like n different point sources, so that they will start generating the wavefronts around them. Okay, they will start generating the wavefronts around them with themselves as the center. Then these wavefronts which I have drawn in the dotted line format are what are called as secondary wavelets. What are they called as? They are called as secondary waves or secondary wavelets. So try to understand. The first continuous line that I have drawn is the wavefront generated by the primary source. Right. Now each point on that wavefront acts as a secondary source for that particular wavelet to get generated. Okay. The second important point is these wavelets are nothing but they are light only again. So these secondary wavelets, what they will do is they will start making the circle, that is the radius of that circle will depend on the speed of the light in that particular medium. These wavelets will start growing in the circular form depending on the speed of that light, speed of the light in that medium. That is the meaning of the secondary point. That is the meaning of the secondary point. Sorry, second point. So secondary wavelets spread out in all directions with speed of light in that medium. And the third most important point is you have drawn the first wavefront, you have drawn the secondary wavelets. Now the question is, how is the new wavefront generated from these wavelets? So if we repeat the story again, then I am clear that if I have a spherical wavefront, on that spherical wavefront I will take multiple dots like this, and these dots act as a source. Not only these dots, every point on this acts as a source only, and the light will start spreading with the speed of the light, with the speed of it in that particular medium. So once you get the secondary wavelet, observe what is the point saying. The new wavefront that is required at any later point means, let's say the speed of the light in that medium is v. After a time vt, this wavefront would have generated, this wavelet would have generated a radius of vt. This wavelet will also have the radius vt, this will also have the radius vt, this will have vt, and this vt according to the second point. Now according to the third point, the new wavefront at any later time is given by the forward envelope. So what is that forward envelope? It is nothing but the tangential surface drawn in the forward direction of the secondary wavelets at that time. Means if I take these wavelets, to these wavelets, if I am able to draw a tangential surface like this, then if I join it like this, then this tangential surface drawn for the secondary wavelets is what we call it as the new wavefront. Okay. So this point is very, very important for you to understand the subsequent concepts of the laws of reflection and laws of refraction, which we will be proving using the wave theory of light.